Okay, hi. In this video, we are going to learn on techniques of integration number 3, which is on the partial fraction or long division. Okay, we consider a function, okay, fx, where we have a fractions p divided by q, where p and q are polynomials and q must not equal to 0. So the conditions, the degree of p must be less than degree of q. Okay, degree of p must be less than degree of q. The second condition, if degree p greater than q, you need to apply long division. Okay, if degree p is greater than q, you need to apply long division. How? So when we apply long division, it will be quotient plus remainder divided by the divisor. So we must know the factors of q. Okay, we must know the factors of q, where it is called linear factors or quadratic factors. Then only we can write the partial fraction. So the method of partial fraction for proper fraction. So this is where degree p is less than degree q. So a linear factor ax plus b power n give a partial fraction like this. Okay, a quadratic factor, we have x power 2, so give a partial fraction like this. Okay, for example, if we have we want to integrate 1 over x plus 1 squared. Okay, so the partial fraction will be a over x plus 1, okay, plus b over x plus 1 squared, right? So if it's different linear factors, x plus 1, x plus 2, it will be a over x plus 1 plus b over x plus 2. Okay, that's how we write it. Okay, if it's quadratic, for example, we have 1 over x squared plus 1. So it will be ax plus b over x squared plus 1. Like that. Huh? So if it's squared like this, the the numerator will be like this. We have x there. If it's just linear factor like this, we just have a constant a, b, c, and so on. But if it's repeated, okay, the same factor, and then we have squared, and then we need to repeat it like this. Okay, never mind, we look at another example. Okay, this example 5, we want to solve this following integral by using partial fraction, because this is in terms of px over qx, right? So this is proper fraction where the degree of p is less than the degree of q, right? So we can straight away find the partial fraction. So we can write 2x minus 3 over x minus 2, x plus 3. So this is a linear factor, because power is 1. So x minus 2 plus b over x plus 3. So that's it. That's a partial fraction that we want. But we need to find what is a and b. So what we do is we multiply both sides by this. Okay, so it will be x plus 3 plus b x minus 2. Okay, we multiply by this one both sides, or we bring this, multiply the whole thing here. So this one cancel, x minus 2 cancel, x plus 3 cancel, so that's why we get this one. Then we will need to solve for a and b. So I want to solve for a first. So at b, the factor is x minus 2. So I will let x equals to 2, so it will become 0 here. 0 here will be 0. When x equals to 2, 2 minus 2 is 0. So we left with ax there. So we substitute x equals to 2. So it's 2 times 2 minus 3 is equals to 5a, right? 5a. Okay, 4 minus 3 will be 1. So a is equals to 1 over 5. How about b? To get b, we let x equals to negative 3, so that it will be 0 here, right? So 2 times negative 3 minus 3 is equals to b times negative 3 minus 2. So it will be negative 5b here. This one will be negative 9, right? Negative 9. So b is equals to 9 over 5. So we get the value of b, we get the value of a. So we'll substitute inside the integral. So this integral is actually equals to integration of 1 over 5 of x minus 2 plus 9 over 5 of x plus 3 dx, right? Because of this, we can write in partial fraction. Okay, so we will integrate now. Before that, maybe we can write it in this simplification. Okay, we get this one. So it will be 1 over 5 ln x minus 2 plus 9 over 5 ln x plus 3 plus c. Don't forget about it. Okay, so we obtain the answer. That's it. So in this type of question, we just need to find the partial fraction. Okay, and then find the value of a and b. We obtain a and b, and after that you substitute in the partial fraction like this, and then we integrate it depending on the types of the function. Okay, that's it for the first example. Okay, next example, let's try this. So now we have 3 factor. Okay, so now you find the partial fraction first. X minus 1, x plus 1, x plus 3. So it's different linear factor. So it should be a, b, c. b over x plus 1 plus c over x plus 3. So we need to multiply everything by the denominator here. So x squared plus 4x plus 1 is equals to a x plus 1 x plus 3 plus b x minus 1 x plus 3 plus c x minus 1 x plus 1. And then we need to find a, b, c. How? Okay, let's check. Okay, to find a, so we must make it 0 here, 0 here. So how? Both has x minus 1, right? X minus 1 here, x minus 1 here. So we can let x equals to 1. So both this term and this term will be eliminated. So we let x is equals to 1. So the whole equation becomes 1 squared plus 4 times 1 plus 1 is equals to a times 1 plus 1 plus 1 plus 4 plus 0. So let us simplify this. 1 plus 4 is 5, 5 plus 1 is 6. Okay, this is 2, this is 5. So 2 times 5 will be 10a. So a is equals to 6 over 10, which is equals to 3 over 5. So we obtain A. Next, to get B, we must make it 0 here and 0 here. As we can see, both has x plus 1 and x plus 1. So we can let x equals to what? Negative 1, right? So the whole thing we have negative 1 now. Sorry, 4 times negative 1 plus 1 equals to B negative 1 minus 1 times negative 1 plus 3. Okay, the rest is 0. So negative 1 minus 4 will be minus 3 plus 1 will be minus 2. Okay. How about the rest? Negative 2. This one is 2. So 2 times negative 2 is negative 4. So B is equals to 1 over 2. Okay, A, B. Now is C. So C, we need to let x equals to. So how to eliminate A and B? So we see both has 3, x plus 3 here. So we let x equals to negative 3. So when we let x equals to negative 3, so it will be, the whole equation will be like this. Is equals to C times negative 3 minus 1, negative 3 plus 1. So here is 9 plus negative 12 will be negative 3 plus 1 will be negative 2. And here is negative 4, here is negative 2, so will be 8C. So C is equals to negative 1 over 4. So we obtain A, B, and C. So we can substitute in this. So the integral here is actually equals to integration of 3 over 5 over x minus 1 plus 1 over 2 over x plus 1 plus negative 1 over 4 over x plus 3 dx. Or we can rewrite it again. 3 over 5 integration of 1 over x minus 1, okay, plus 1 over 2 integration of 1 over x plus 1 minus 1 over 4 integration of 1 over x plus 3 dx. All of these have dx, sorry. Okay, now we can integrate them. We get the answer equals to 3 over 5 ln x minus 1 plus 1 over 2 ln x plus 1 minus 1 over 4 ln x plus 3 plus c. Okay, that's it. Oh, should be 4 here. Oh, here is wrong here. It should be 3 here, right? 3. So it's 4 here. So here is 8. So that's why that equals to 3 over 4 there. So please be careful with your calculation, okay? Sometimes you do careless mistake. So you change the final answer. Okay, the rest is okay. So next is I'm going to show under repetitive linear factor like this. So it should be, the partial fraction should be a over x plus 2 plus b over x plus 2 squared like this, because it's repeated. So now a plus x plus 2 plus b, right? So to get b Okay, this one, maybe we want to compare. Plus 7 is equals to ax plus 2a plus b. So we will compare the term with which has x and the term without the x. Okay, so this is another way of finding the a, b, c. So 6x must be equals to ax, so a must be equals to 6. So since we know that a is equals to 6, okay, second equation we have 7 equals to 2a plus b, 2 times 6 plus b, so b must be equals to 7 minus 12, which is equals to negative 5, right? Is equals to negative 5 or positive 5? Negative. So when we put in the integration or in the partial fraction, integral here is actually equals to 6 over x plus 2 minus 5 over x plus 2 squared dx. Okay, or we can write like this: 6 1 over x plus 2 minus 5 integration of x plus 2 power negative 2 dx. Okay, so now we want to integrate this. 6 ln x plus 2 minus 5. Okay, how do we integrate this? X plus 2 plus power negative 2 plus 1. X plus 2 negative 1 divide by negative 1. See. So we obtain it equals to 6 ln x plus 2 plus 5 x plus 2 negative 1 c, or we can write it 5 divided by x plus 2 plus c. Okay, that's it. Okay, this one maybe you can try to do it. This is a simple equation. First of all, you try to factor it out. Can you factor it? X 3 2, right? So it's actually equals to integration of, or we can just write like this: x plus 1 divided by x plus 2 x plus 3. Okay, so sometimes it's not factored out, it's not factorized yet, so you need to factor it. So you need to factorize it. So a over x plus 2 plus b over x plus 3. The rest will be very easy. So continue the same step. X plus 2, so we let x is equals to negative 2, so negative 2 plus 1 is equals to a times negative 2 plus 3, so a must be equals to negative 1. Okay, how about to find b, we let x is equals to negative 3, so negative 3 plus 1 is equals to b, negative 3 times negative 3 plus 2, so it's negative 1 here, so b is equals to 2. Alright, we obtain a and b. So this is actually equals to integration of negative 1 over x plus 2 plus 2 over x plus 3 dx. Okay, we can rewrite it: negative integration 1 over x plus 2 dx plus 2 integration of 1 over x plus 3 dx. So we integrate it now, we'll obtain negative ln x plus 2 plus 2 ln x plus 3 plus c. Okay, that's it. Okay, next technique of integration by using partial fraction is we need to apply long division first. Why? Because the degree of p is greater than the degree of q. So what is the result of the long division? It's like this. The quotient, okay, plus the remainder divided by the divided. Okay, now is a partial fraction that we need to perform long division. Okay, so this example. Okay, now we perform long division. Long division is 2x minus 3. 2x power 3 minus 4x squared minus x minus 3. Okay, so how to get 2x cubed from x squared? We multiply by 2x, right? So multiply by 2x. So we multiply the whole thing. Okay, and then this one minus 4x squared. And then minus 6x. Okay, minus the whole thing here. We'll obtain this one 0. Negative plus negative 4x squared plus 4x squared will be 0. Negative x plus 6x will be 5x minus 3. So that's it. You don't have to continue because 5x, the degree is lower than the x squared. So for A, the result of the division is, okay, the quotient 2x plus the remainder divide by the, sorry, okay, 2x plus 5x minus 3 over x squared minus 2x minus 3. So now we will have to integrate this one actually. Dx. So how do we integrate this? So x squared minus 2x minus 3. X negative 3 plus 1, right? Okay. So this one integrate 2x dx plus integration of 5x minus 3 over x squared minus 2x minus 3 dx. So this one you need to use partial fraction. Okay, let us write it here. 5x minus 3 over x minus 3, x plus 1 is equals to a over x minus 3 plus b over x plus 1. So you find what is a and b. So in the end you obtain a is equals to and b is equals to what? 3 and 2. Okay, calculate it like we have done before. So we can integrate. So we continue here, this one. 2x will get x squared plus integration of 2 1 over x minus 3 plus 2 over 1 x plus 1 dx. So we obtain x squared plus 2 ln x minus 3 plus 2 ln, this one is 3, sorry, 3 here, 3 ln x plus 1 plus c. Okay, that's it. The same thing for b. For b it is integration 9x cubed minus 3x plus 1. This is cube over x cubed minus x squared. So it's x cubed over x cubed. So this one also we need to use long division. So we divide. Okay. So times 9x squared minus, so you obtain 0, negative 3, okay, 0 minus negative 9x squared will be 9x squared, negative 3x minus 0 will be negative 3x, okay, and then plus 1. So that's it. So this is actually equals to 9 plus the remainder divided by the quotient, 9x squared minus 3x plus 1 divided by x cubed minus x. So how to solve this one? We actually want to integrate this one. So now we focus on this. So it will be 9x squared minus 3x plus 1 divided by x squared minus x minus 1, like this. So the coefficient will be a over x plus b over x squared plus c over x minus 1, like this. So what is the value of a, b, c? Okay, we can calculate one by one. So 9x squared minus 3x plus 1 is equals to a x minus 1 plus b x minus 1 plus c x squared. Okay, so I think we better expand everything. So it will be 9x squared minus 3x plus 1 equals to ax squared minus ax plus bx minus b plus c minus b plus cx squared. Okay, so now we collect term, then we compare x squared x and x power 0. So x squared is equals to 9 is equals to a plus c. For terms x, negative 3 is equals to negative a plus b. For terms without x, okay, 1 is equals to negative b only, right? Negative b. So we straight away obtain b is equals to negative 1, and then we substitute here. So a is equals to negative 1. So negative 1 plus 3 will be 2. And c is equals to 7. So that's it. So it's actually we want to integrate 9 dx plus integration of 2 over x dx, okay, minus integration of 1 over x squared dx plus integration of 7 over x minus 1 dx. So what's the answer? It will be 9x plus 2 ln x. Okay, this one will be, okay, x power negative 2 plus 1 will be, okay, plus x 1 over x, 1 over x plus 7 ln x plus c. That's it. So that's it for partial fraction. Please let me know if you have any problem. Okay, bye.